Hello, my name is Ardi and we are going to solve practice problems of chapter 2 from Alexander and Sadiku. Okay, let's start. So we are going to solve practice problem 2.1 from Sadiku book. Let's read the problem first. The essential component of a toaster is an electrical element, a resistor, that converts electrical energy to heat energy. How much current is drawn by a toaster with a resistance of 15 ohm at 110 volt? Okay, so now let's extract the known that we have from the problem. So we have a resistor here, and then the value of a resistor is 15 ohm, and then the resistor is given a voltage of 110 volt, and the question is asking us for the current. So current here as the question. So we have this as our noun. So we have a resistor. That's right, with a value of 15 ohm, and then we give this resistor voltage here, which is 110, and we are asked to find the current that pass through this resistor. Okay, now let's jump into our solution. If we know the voltage and the resistance, we can directly use Ohm's law to find out the answer. So Ohm's law said that the current is equal to voltage divided by the resistance, and the voltage is 110. So let's plug that in, 110. And then the resistance is 15 divided by 15. And this is not a nice number, so I just want to plug this into calculator. Let's plug that into calculator. 110 divided by 15, and that will be 7.333. Okay, now we have 7.333, and the unit is ampere, because this is voltage and this is ohm. So we will have 7.333 ampere here, and you can check that that is exactly the same as our answer here. Okay, now this is for practice problem 2.1, and let's move on to next problem, which is practice problem 2.2. So let's read the problem first. For the circuit shown in the figure 2.9, so this is the figure, calculate the voltage V, the conductance G, and the power P. Okay, so now from this circuit, what do we know here? We have 3 milliampere current source here, and it is connected in series with this resistance. So that means that we have this I here is also 3 milliampere here. And then from the current, we know the resistance here, we can directly find out the voltage first. Okay, so now for the first question, the voltage, we can use the Ohm's law. So Ohm's law said that the voltage is equal to the current multiplied by the resistance, and then the current is 3 milliampere. So let's just write 3, and then the resistance is 10 kilo ohm. So let's just write 10, and we have 30. And the unit, because this is milliampere and this is 10 kilo ohm, the milli and kilo will cancel each other, so we have 30. So our V is 30. As you can see here, this is the same as this one, right? Which is a good start. Okay, so now we have the question number 2, which is conductance. Okay, conductance. Remember that conductance is just the inverse of resistance. So we'll have 1 over R. And so we will have G is equal to 1 divided by 10. And because this is kilo, I want to convert that into ohm, so we have 10 to the 4. Or we can write this as 10 to the minus 4. And 1 over ohm will be Siemens. Or to make it this nice number, we convert it into microsiemens. So we multiply it by 1 million, and we will have 100 microsiemens. So our G here is 100 microsiemens. And again, if we check with the answer key, that is a good place. Here, we are in the good place. Okay, now let's do the number 3. For this number 3, we are asked for power. Remember that power is just a multiplication of voltage multiplied by current. We have our voltage from the problem number 1, so we'll just plug 30 here. And then the current is 3 milliampere, so I'll have 3, but this is voltage, so this is milliampere, and so we will multiply it by 10 to the minus 3. So we will have 90 multiplied by 10 to the minus 3 watt. Or we can convert this into a nice number, which is 90 milliwatt. And that is the same as our answer key. Okay, so we have done practice problem 2. Let's move on to the next problem. Okay, a resistor absorbs an instantaneous power of 30 cosine squared t milliwatt when connected to a voltage source. P is equal to 15 cosine t volt. Find I and R. Okay, so let's draw the circuit first. So we have a voltage source, which is the value V is 15 cosine t volt. And then this connected to a resistor. And we have the power here. The power of this resistor is 30 cosine squared t milliwatt. Okay, now let's see what we are asked to find. The first one is I. Okay, we know that P is equal to voltage multiplied by the current, but we know the power, and we also know the voltage, so we just manipulate this formula into I is equal to P divided by V. Let's just plug the value. We have our power here, which is 30 cosine squared t milliwatt. Okay, let's just write the unit there. And then the voltage is 15 cosine of t volt. Okay, now this is cosine t and this square will cancel, leaving only cosine in the numerator. And then 15 and 30 will cancel into 2. So we'll have 2 cosine t, and then this is milliwatt. Milliwatt divided by volt will become milliampere. So this is our current here. As you can see, our answer is the same as the answer key, so that this is a good good place for us. And then the second one, we are asked to find R. Okay, I think this is R. Okay, now we know the voltage, we know the power, we know the current, so we can easily find out the resistance. By using Ohm's law, we can see that this is voltage divided by the current. Okay, our voltage is 15 cosine t, and our current is 2 cosine t. And then the unit of our voltage is volt, and then the unit of our current is milliampere. Okay, this cosine t will cancel each other, and 15 divided by 2 is 7.5. Voltage divided by milliampere will become kilo ohm. So our resistance value here will be 7.5 kilo ohm, which is the same as given in the problem. So this one. Okay, this is for practice problem 2.3. So let's move on to other practice problem. So practice problem 2.4. How many branches and nodes does the circuit in the figure 2.14 have? Identify the elements that are in series and in parallel. So this is the circuit here, and I will mark the nodes one by one. So this is the first one, we are asked to find the nodes. So this is clearly the nodes here. This is nodes number 1. And then this is nodes number 2. And then the bottom one here is nodes number 3. So we will have 3 nodes. And then let's use another color for branches. We'll use branches. Okay, our branches, how many is the branches? So this is branch number 1. And then this is branch number 2 here. So this is 1, 2, and this is branches number 3, and this is number 4, and the last one is this one. So we'll have 5 branches. Okay, now for number 3, identify the series and parallel element. Series, I don't think we have series elements from here. Yeah, if we simplify this, we can find some, but in the current configuration, there is no series configuration. And for parallel, okay, we have this one, the 1 ohm and 2 ohm. So 1 ohm parallel with 2 ohm resistor. So this is 1, and then this 10 volt voltage source is parallel with this 4 ohm. So we'll have 10 volt parallel with that 4 ohm. And I think we are done for this problem. Okay, let's move on to next problem. Okay, now we are asked to find V1 and V2 in this circuit. I think we should redraw this circuit first. So let's maybe some addition here. Okay, maybe we can do this one. Drop this maybe. Drop and do some resize. Okay, good. Now let's resize this so we have a better view. Okay, so now we have better view. let's back to that. And this is a fine circuit to do KVL. Okay, let's do drawing here. So let's draw the loops here. And then let's name these loops as IA. So the current that pass through these loops is IA. And then we are using KVL at loop IA. And KVL said that the sum of the voltage in a loop will equal to 0. So we start one by one. So in this voltage source here, the current is flowing from negative to positive, so we will have negative value, and the value is 32 ohm. And then plus 4, this is a resistance, so 4. We have voltage here, we need voltage, but we have resistance, so we multiply this resistance by the current, so I will have IA here. And then again we have voltage source, and the current is entering from negative to positive, so the sign will be negative, but the value of the voltage source here is negative 8, so let's plug that in. And then again we have a resistor here, 2 ohm, so we have 2, but we need voltage, so we multiply this by I. And all of this will equal to 0. And let's see what can we simplify here. I can move this minus 32 and this minus 8 maybe to the right hand side, but first I want to make the sign easier to see, so minus and minus becomes plus, so that is plus 8. And then for IA, plus 2IA will becomes 6IA. Is it? Yeah, I think that's true. And then 6IA becomes 32 minus 8, right? And so I'll have 6IA is equal to 24, and then IA is 4 ampere. Okay, so this is a grid glue here, and from this IA we can calculate V1. So V1 is IA multiplied by R, and our R is 4 ohm and our IA is 4. So I'll have that V1 is equal to 16 volt. And then for V2 we have to be careful here because the sign of the voltage is negative here, but we assume that our current is going from here to here, so our voltage when we multiply IA by 2 ohm will be this polarity here. So let's name this as V2 prime maybe. Yeah, okay, so now we have V2 prime is equal to IA multiplied by R. So IA is 4 ampere, and then our R is 2, so we will have that will equal to 8 ampere. So this is V2 prime. But remember, we are asked when the polarity of the positive one is here and the negative one is here, so we can just invert the sign of V2. So V2 will be the negative of V2 prime. So I'll have V2 is equal, or this is not ampere, this is volt. It's volt, so minus of 8 volt. I'll have minus 8 volt. And as you can see here, we have V1 is equal to 16 volt and V2 is equal to minus 8 volt, which is the same as the answer key given by the problem. Okay, I think that's enough for practice problem 2.5. Let's move on to the next problem. Okay, this is practice problem 2.6, and yeah, let's do something with the picture. Okay, let's do this. Picture, yeah. Let's copy the picture. And then let's crop this so I get the circuit. And let's resize this so we can see this more clearly. Okay, let's see what they are asked for. Find Vx and V0. So we are asked to find Vx and V0 in the circuit of figure 2.24. So this is the figure. We are asked to find Vx here and V0 here. Again, this is a perfect circuit to do KVL. So let's use the pen here. Okay, let's do KVL at this loop. Okay, let's name this loop IA again maybe. Yeah, it's the same as the previous problem, but it's okay. So we will use KVL at loop IA. Okay, KVL said that the sum of the voltage will equal to 0 in a loop. Okay, we will need to start it one by one. So this is the voltage source and it's flowing from negative to positive, so the sign will be negative and the value is 70. And then we have a resistance of 10 ohm. But it is resistance and we need voltage, so we multiply it by IA. And then again we found the dependent voltage source, and the sign will be positive because it is entering from the positive polarity, so I have plus, and the value is 2Vx. And then one more, we have 5 ohm here, plus 5. But it is resistance and we need voltage, so we multiply that by IA. I'll have IA and that will equal to 0. Okay, let's move this constant to the right hand side and let's add up this IA. So I'll have 15 IA plus 2Vx is equal to 70. Okay, now let's see what Vx is. Okay, Vx is this one. So what can we do about it? So remember that we have IA pass through here and Vx is the voltage between this resistance. So I'll have Vx is equal to, what is it? Remember the Ohm's law, V is equal to I multiplied by R, right? So Vx is IA multiplied by the resistance, so 10 ohm, right? Or in other words, Vx is 10 IA. So we can plug this Vx into this Vx. So we'll have 15 IA plus 2 multiplied by 10 IA, which is 20 IA. Okay, and that will equal to 70. And we can add up this, so 35 IA is equal to 70. And so we can conclude that our loop value here, loop current here is 2 ampere. Okay. So we have a very important value here. So I have IA is 2. So now from here we know that Vx is 10 IA. So we can conclude that Vx is 10 multiplied by 2, which means that Vx is 20. So now let's put it in a box, inside a box. And then what can we do here? So we are asked to find V0. Again, we have to be very careful here because IA is flowing from this side to this side. So the power polarity from this KVL calculation will be like this. This is the positive. The right one is positive polarity and the left one is negative polarity. So let's name this voltage that here is maybe, what is it? V0 prime. So we have V0 prime is equal to IA multiplied by 5. So our IA, what is our IA is 2, and then multiplied by 5. So V0 prime is 10 volt. But we are not asked to find V0 prime, but V0, which is the negative polarity of this V0 prime. So we will have that as the inverse of this one. The, what is it? Additional inverse of this. So I will have V0 is minus 10. So we have found Vx and V0, which is 20 and minus 10. And if you see here, that is the same as the answers given in the problem. Okay, now let's move on to another problem, which is practice problem 2.7, and the question is to find V0 and I0 in the circuit. Okay, as usual, I will copy this circuit first. So let's copy that circuit and make it larger. Okay, let's crop this. I think the picture will be a little bit blurry, but I don't know. Maybe it's best to resize this. Okay, I think this is a good goal. So we have this circuit here, and I think this circuit is a perfect example for using KCL. So when we are using KCL, the first thing you need is to set your ground. So you can pick any node as your reference voltage. So let's choose the bottommost here as our reference voltage, and then this reference voltage will equal to 0. And because this is V0 from the ground, so we'll have this node here will have the value of V0 with respect to ground. And because all the elements are in parallel, the voltage will be the same. And then the second one will be analyze. Analyze that the sum of the current that goes in is equal to the sum of the current that goes out. Okay, let's assume the direction of the current. So this is going here. Yeah, this is going up. So if you have current source, just follow the arrow, and then this one is already given, so we put it like that. And I want to assume that this also going down here. Okay, now let's do KCL at node. What node is it? It is V0. So KCL at node V0. And KCL said that this one, the sum of the current that goes in is equal to the sum of the current that goes out. Let's see what current that goes in and what current that goes out. So the only current that goes in is from this 9 ampere current source. So I need to put 9 here. And then we have the current that pass through this 2 ohm resistor as the current that goes out, and this is also goes out, and this is also goes out. So here we have I0 here, but I0 is no other than V0 divided by 2, right? So let's plug that V0 divided by 2 because of Ohm's law, right? And then plus this current here. This current is I0 over 4. So let's put I0 over 4 here. And then this one, this current is no other than V0 divided by 8. Okay, now let's multiply this by 8 so we don't have any denominator here. So if we multiply this by 8, we have 72 and then 4 EO, and then plus 2 I0, and then plus 0, and I will have 72 is equal to, what is it, 5 E0 plus 2 I0. So now we need to manipulate this so it only have one variable. And it can be done by using the fact that I0 is V0 divided by 2. So I'll have 72 is equal to 5 V0 plus 2 multiplied by 0 divided by 0 divided by 2. And this will cancel each other. So I'll have 72 is equal to 6 V0, or V0 is equal to 12 volt. And if we see here, we have 12 volt and in the answer. And I0, what is I0? I0 is just V0 divided by 2, right? So V0 is 12 divided by 2, and so from here I get I0 is equal to 6 ampere, which is the same as this answer from the problem. Okay, I think that's enough for practice problem 2.7, and then we move on to the next problem. So we are asked to find the current and voltages in the circuit shown in this figure. Okay, let's do some copy pasting again. Let's copy the circuit and then let's resize them. Circuit is so small, guys. Let's resize it. Okay, it's a little bit blurry, but I think you can still see it. Okay, find the current and voltage. I think if we are given this circuit and we check this as our ground, so the voltage here will be 0, and we name this here as our node, but our node here is the same as V2 because this is the ground, so and V2 is here, so this is not V2, And we can do, what we can do is KCL at node V2. KCL at node. Okay, now we have given the direction of the current. So let's see what KCL does. So the KCL said that the sum of the current that goes in is equal to the sum of the current that goes out. Okay, the only current that goes in is I1. So let's rewrite that I1. And then the current that goes out is I2 and I3. So I'll have I2 plus I3. Okay, now we have I1 here. And we can calculate I1 by using Ohm's law. Because this node here is 10 volt from the ground. So we have 10 volt voltage source. So we'll have 10 volt here. And I1 here is 10 minus V2 divided by 2. So the difference between voltage divided by the resistance. And then for I2, it is V2 divided by 8, right? It is V2 minus the voltage here, but it is 0, so I don't need to write it. And V2 divided by the resistance between the voltage, so it is 8 plus I3. I3 is here, it is between V2 and this is 6, but the polarity of positive is here, so the value of the voltage here will be minus 6. So I'll have V2 minus 6 divided by the resistance between the voltage, which is 4. Okay, so now let's do what can we do to simplify this. Okay, I want to make this sign positive first, so let's just copy that. Minus V2 divided by 2 is equal to V2 divided by 8 plus, what is it? V2 plus 6 divided by 4. Okay, now let's multiply all of this by 8, so we don't have the denominator here. So we'll have 40 minus 4V2 is equal to V2 plus, what is it? This is 2V2 plus 12. Okay, we can move all the constant to the left hand side and all with V2 to the right hand side. So 40 minus 12, it is 28, right? I'll have 28 on the left hand side, and then V2 plus 2V2 is 3V2, 3V2 plus 4V2 will be 7V2. So from here I will have V2 is equal to 4 volt, which is great. Why? Because we can find out the other voltage from here. So V1 is the difference between this node and this node, so I'll have, it will be 10 minus V2, and we already have V2, so V1 is 10 minus 4, which is 6 volt. And from here we can find the V3. So V3 is just V2 minus 6, or V2 plus 6, and V2 is 4 volt, so I will have V3 is equal to 10 volt. So we have all the voltage covered, and it is the same as the answer given in the problem, right? And then for the current, let's see what the current is. So I1 is just V1 divided by 2, right? So I'll have V1 6 divided by the resistance, which is 2. So I1 is 3 ampere. and I2, I better write it here. So it is here, and this might be a better place for I3. So I2 is just V2 divided by 8, which is 4 divided by 8, which is 0.5 ampere or 500. So this is for I2, and for I3 it is just V3 divided by this one, 4 ohm. So I'll have 10 divided by 4, and 10 divided by 4, what is it? 5 divided by 2, so maybe, okay, stupid or what? But this is 2.5 ampere. Yeah, it's kind of different from the answer, but I'm pretty sure I did not miscalculate things, so maybe the answer key is wrong. Let's see. Yeah, this is, our V2 is 4, and then this will be making, yeah, we are right, 10 divided by 4 is 2.5, and I think the answer key is wrong. Okay, and I think this is enough for practice problem 2.8. Okay, now let's move on to the next problem. Okay, we have practice problem 2.9. Okay, let's see. By combining the resistor in the figure, find the resistor equivalent. Okay, let's do that. So the first thing that we need to see easily here, you can see easily, is this 3 resistor here is in series. So that means that we can just add them up. So that will be 4 ohm plus 5 ohm plus 3 ohm, and that will be 12 ohm, right? So that resistance here will be 12 ohm, and then that 12 ohm is parallel with this resistance here, which is 4 ohm. And let's use another color here, maybe red or maybe blue. Yeah, so we'll have 4 ohm in parallel with 12 ohm, and 4 parallel with 12 will be 4 multiplied by 12 divided by 4 plus 12, or this is 48 divided by 16, which is 3 ohm. Yeah, if I don't making stupid mistake there. So this 4 ohm and this bunch of resistor making it 3 ohm. So let's just erase this and let's make it 3 ohm. So all of this will be ohm, and then that 3 ohm along with this 3 ohm resistor forming a series circuit. So 3 plus 3 will be 6, right? 6 ohm. So we'll have 3 plus 3 from here. Let's see. So the next one is 3 ohm plus 3 ohm. So this one is in series with all of this, and that will equal to 6 ohm. And then that 6 ohm, all of this one is 6 ohm, right? That I have highlighted is 6 ohm. And that will join with this 6 ohm. So for the next step, I will have 6 ohm parallel with 6 ohm. So I'll have 6 times 6 divided by 6 plus 6, which is 36 divided by 12, or it is 3 ohm. Okay, and then the last one, we have that resistor of 4 ohm and 3 ohm. So I'll have 4 ohm here and 3 ohm here, and this will form a series resistance. And from there we can just do a simple calculation, which is 4 ohm plus 3 ohm plus 3 ohm, which is equal to 10 ohm. So the equivalent resistor here is 10 ohm. Yeah, it is the same as the answer given in the problem, so our answer is correct. Okay, now let's move on to practice problem 2.10. And again, we are asked to find the equivalent circuit. Okay, let's start from this one first. That the first one that I see here, we have a 20 ohm and 5 ohm resistor connected in parallel. So from here I will have 20 ohm parallel with 5 ohm, and this will be 20 multiplied by 5 divided by 20 plus 5, or this is 100 divided by 25, and that is 4 ohm. And that 4 ohm here, so that 4 ohm is in series with this 1 ohm. So 4 plus 1 is 5 ohm. So the next step will be 4 ohm plus 1 ohm. That will be 5 ohm. And then this 5 ohm, yeah, as you can see here, 5 ohm, it is parallel with this 20 ohm resistor. So I will have, what is it, 5 ohm parallel with 20 ohm, and that will be equal to 4 ohm again, right? So all of this will combine into one single resistor of 4 ohm. And then what can we do from here? Okay, let's redraw this. So I think we need to redraw this. Okay, we have that 16 ohm, and then we still have that vertical resistor of 9 ohm, and then we still have the 2 ohm resistor here. Okay, we still have 2 ohm here, but from all of this we form a single resistor of 4 ohm. Yeah, single resistor of 4 ohm. And then we still have this diagonal resistor here, which is 18 ohm, and it is connected to port B, and it is shorted with this one. Okay, that means that we have this 18 is parallel with 9. So let's calculate that 18 with 9. So 18 ohm parallel with 9 ohm. So we'll have 18 multiplied by 9 divided by 18 plus 9. So to make this calculation easier, I just leave it as it on the top, and then on the bottom this is 27, right? So we have this cancelled, and all of this will cancel in 6 ohm. So I can erase this, all of this, and replace it with 6 ohm. Okay, this is 6 ohm, and this is still connected to B. From here we can see that this is in series with this one, so and then parallel with this one. So we have 6 and 6 in parallel. So 6 and 6 in parallel, that will equal to 6 times 6 divided by 6 plus 6. And 36 divided by 12 is 3 ohm. And lastly, we will have this kind of resistor, 16 ohm. And then we have this one. All of this as 3 ohm. And lastly, we have RAB. It's just that two resistor in series, which is 16 ohm plus 3 ohm. So we will have the RAB is equal to 19 ohm. And this is the same answer with the answer given. Okay, I think this is enough for practice problem 2.10. Let's move on to practice problem 2.11. Okay, calculate the G equivalent of the figure 2.41. Okay, because we are trying to find the conductance and I don't remember any of the formula of conductance, let's just use this. Let's just convert all of this conductance unit into resistance unit and we will calculate in the domain. So for Siemens is 1 over 4 ohm and 6 Siemens is 1 over 6, and then this is 1 over 12, this is 1 over 8, and this is 1 over 2, and all of this in ohm. Okay, so now let's start with this one, this very bottom resistor here, between 1 over 6 and 1 over 12. So we will have 1 over 6 in parallel with 1 over 12. Okay, so now this will be complicated algebra here. 16, 1 over 6, 1 over 12 divided by 1 over 6 plus 1 over. Okay, this may be a little bit hard. So 1 over 6 is 2 over 12, 2 over 12 plus this 1 over 12, that is 3 over 12, right? And 3 over 3 over 12, and actually we can cancel this out. So yeah, we have 3 here, and 1 over 6 divided by 3 is 1 over 16. 1 over 18, I mean. Yeah, that will be 1 over 18. Okay. So now that 1 over 18 is in parallel with this resistor here. So let's see that one. So 1 over 18 is in parallel with 1 half. So we'll have 1 over 18 multiplied. Yeah, I mean multiplied. It's multiplied by, and then remember that 1 half is 9 over 18, so I will have 10 over 18 here. So we will have this one, and this will equal to 1 over 20. So all the highlighted part here will become 1 over ohm. And then if we can see here, you can see here this resistor here and this resistor here is connected in parallel, right? So for that resistor only, we will have 1 over 8 in parallel with 1 over 4. So that means that 1 over 8 multiplied by 1 over 4. And then remember that 1 over 4 is 2 over 8. So I will have 3 over 8 here. And we can cancel this 8. and then leave 1/4 divided by 3, which is 1/12. So for finding the R equivalent, we need to find out 1/20 in parallel with 1/12. Okay, let's do the calculation. 1/20 divided by 1/12 divided by 1/20 plus 1/12. Okay, this math will be complicated. Maybe make them in the 60. Okay, now the numerator will be 1/200, and then that will be divided with this one. This one will be 3/60. 3/60 plus 5/60, and that means that 240 multiplied by 60 divided by 8, right? And this will be cancel each other, is equal to 4. And then the resistance will be 1/30 ohm resistance, or the conductance G equivalent will be 1/R equivalent. So that G equivalent will be 30 Siemens. And that's different. I think maybe I made a mistake. Okay, let me know if you found my mistake here, because I'm tired right now. Okay, just move on, because all this fraction is confusing. Maybe next time. So let's move on to practice problem 2.12. Find V1 and V2 in the circuit shown in the figure of 2.41. Also calculate I1 and I2 and the power dissipated in the 12 ohm and 40 ohm resistor. Okay, let's see what can we do from here. For the circuit, let's just copy paste like usual. Let's do some copying and resizing. This is good. Okay, now what can we do from here? Okay, we are asked to find V1 and V2. Okay, V1 and V2, and then I1 and I2. I think using nodal analysis. Nodal analysis is just KCL here. So we put this as our ground, and let's name this node as our node A. And then the value of this node here is 30 volt, because it is 30 volt from the ground because of this voltage source. So this is 30 volt. And we just need to analyze the node A. So we need to use KCL at node A. Okay, let's assume the direction of the current, especially at this node here, because it's unknown. I1 is going to the right and I2 is going to the bottom, but I still need to do one more. thing here, this current here. Okay, now let's do KCL. And KCL said that the sum of the current that goes in is equal to the sum of the current that goes out. Okay, the sum of the current that goes in, there are two currents that goes in, 1 and 2, and two currents that goes out, 1 and 2. The first current that goes in is I1, but I1 can be calculated as 30 minus this one, minus VA. So 30 minus VA divided by the resistance. So 30 minus VA divided by 12. And it is also the same, but the difference is the resistance between it is 6 ohm. So I'll have 30 minus VA divided by 6. And then the currents that goes out, there are two currents that goes out. The first one will be this current here, which is VA divided by 10. And then I2 is just VA divided by 40, right? As VA divided by. Okay, let's do some algebraic manipulation here. So if we make the denominator 12 on the left hand side, we can see that this will be 30 minus VA divided by 12 plus, what is it, 60 minus 2 VA divided by 12. And then we can make the denominator 40 on the right hand side, 40. So this will become 4 VA and plus VA. So we'll have 5 VA. And 5 VA divided by 40, this 5 and 40 can cancel each other, becomes 8. And for the left hand side here, we can see that this is 90 minus 3 VA divided by 12 is equal to VA divided by 8. Let's cross multiply from here. 720 minus 24 VA is equal to 12 VA. And then from here I will have 720 is equal to 36 VA. So we'll have VA is equal to 20 volt. Okay, we know VA, and from VA we can find everything in the circuit. Yeah, okay. The first one is V1. So V1 is just this one, 30 minus VA. 30 minus VA. And so V1 is 30 minus 20, which is 10 volt. Okay. The second one is V2. And V2 is the same as VA because it is the same from the ground to this node, right? So V2 is equal to VA, or V2 is 20 volt. 20 volt. So we already find out V1 and V2, and we are asked to find I1 and I2. I1 and I2. So I1 is here, and that will be V1 divided by R. So V1 is 10, and the resistance between it is 12. Okay, the numbers is not good. So 10 divided by 12. Let's use calculator. 10 divided by. Okay, that is in ampere, so we can just plug. We can just multiply it by 1000 to get it 833 milliampere. So this is for I1. And then for I2 is just V2 divided by R, and our V2 is 20, and the resistance here is 40, so it is half ampere or 500 milliampere. Okay. And then the power dissipated in the 12 and 40, so the power is just multiplication of voltage and current, and in the 12 volt we can just multiply 10 by the current. The current is this one, so 3.3 milliampere, so we will have 8.333. This is not watt but in milliwatt, right? Yeah, okay, so this is P1, and then for P2 we will have P multiplied by I again, and our voltage there is 20, and then that is 500 milliampere or half ampere, so that means that we will have 10 watt here. And I think we have found all the value here. Please let me know if I made mistakes, especially in this one, because it is different from the answer keys. Yeah, but I don't think I made a mistake. Okay, now let's move on to the next problem. So we are asked to find the V1 and V2, and then the power dissipated, and then the power supplied. Okay, let's see. Again, this is the circuit. Let's copy and paste this. Copy and paste this so we can calculate them better. It's been up. We put it here. Okay, let's see what can we do from here. Let's set our bottommost node here as our ground. As usual, in the ground V is equal to 0, and then we need to do KVL at this node, right? Let's name this node A. I mean KCL. So KCL at node A. And I want to assume the direction of the current. So I want all but this current source is going down. So all of this is going down. So the current that goes in is equal to the current that goes out according to KCL, and the current that goes in is only from this 30 milliampere current source, and all the other currents is going out. The first one is from this one, which is VA divided by 1 plus 3, which is 4, and then the second one is just VA divided by 5, and the third one is just VA divided by 20. So let's do some algebraic manipulation here. If you have 30 on the left hand side, let's make all the denominator 20. So we will have 5 VA plus 4 VA plus VA divided by 20. So we'll have 30 is equal to, what is this one? 5 plus 5, that is 10 A, and this is 20. And solving for all this, we'll have us got VA. VA is equal to, what is it? It is 60, right? 60 volt. Okay. We have VA is equal to 60 volt. So if VA is 60 volt, we can find everything else. So V1 is here, V2 is here. So the easiest thing to do is find V2, because V2 is equal to VA, and then V2 is 60 volt. Okay, this is the first one. And then V1 can be found using voltage divider. So we have 3 kilo ohm here and 1 kilo ohm here. So V1 is just 3 divided by 3 plus 1 multiplied by VA. VA is 60 volt. 60 volt. And that means that we have 3 over 4 multiplied by 60. And that means that V1 is equal to 45 volt. 45 volt. So we have answered the question A. So we have answered the question A. And then for the question B, the power dissipated in the 3 kilo ohm. Okay, the power dissipated in the 3 kilo ohm. We know the voltage. So remember that P is equal to V multiplied by I, but I is just P divided by R, right? So we'll have P is equal to V squared divided by R. And the power dissipated by 3 kilo ohm resistor here will be, okay, P1, it is 45 square divided by 3, right? Kilo ohm. So let's do that. That is 45 multiplied by 45 divided by 3. And we have 3 and 15 here. And 45 multiplied by 15, what is it? 45 multiplied by 15 is 675. So 675. And because this is kilo, so this will be milliwatt. And for the power here, it is also the same. So P2 is P squared, so 60 times 60 divided by 20. So we'll have this cancel, and then 60 multiplied by 3 is 180 watt. So this is for P. Okay, and then the power supplied by the current source. Okay, the current source have I, the current is 30 milliampere, but the voltage here it's the same because all of this is in parallel, so the voltage here is also VA. And from there we know that P is equal to V multiplied by I, and our voltage will be 60, and then our current will be 30 milliampere. So I'll have 1800 and this will be milliwatt, and so our power here will be 1.8 watt, and all of them is the same as the answer given. Okay. Okay, let's move on to the next problem. Okay, now we have practice problem 2.14, and for doing this we just need to plug into this formula. Okay, so now what we need to do is calculate the numerator first, because all of them are the same. Okay, we see here all of them is the same. So it is the R1 R2 plus R2 R3 plus R1 R3. Okay, now R1 multiplied by R2, which is 10 multiplied by 20, and then plus R2 multiplied by R3, so I have 20 multiplied by 40, and then the last one is R1 multiplied by R3, so I have 10 multiplied by 40. Okay, so now we will have this one will be 200 plus 800 plus 400, and this will make it 1400. Okay, so now RA is just this one, 1400 divided by R1, which is 10. So I'll have, what is it, 144. And then RB will be 1400 divided by R2. Our R2 is 20 ohm. So I will have this one is equal to 70. And lastly, it is RC, which is 1400 divided by R3, which is 40. And that will make this 35 ohm. And so we can draw the delta network from RA, RB, and C, but I don't think we need to draw that because we already have the value of each resistor. So, and our answer is the same as the answers given in the problem. Okay, now one more problems to solve, which is practice problem 2.15 from Sadiku book. So for the bridge network in figure 2.54, find the resistance of AB and I. Okay, see what can we do here. I think I will copy the circuit first and then crop them. Crop it. English is confusing. I'm sorry because English is not my native language. Okay, now what can we do from here? Okay, we are asked to find this I from here. The problem is I don't remember all the formula for Y delta. So my solution will involve a simple but maybe long circuit analysis. So I will do mesh analysis from here. Let's make this as loop number 1. this as loop number 2 and this here as loop number 3. So let's analyze the loops one by one. So at loop 1, okay, and in each loop we need to use KVL. It states that the sum of voltage will equal to 0. So we have this voltage source here. So I will have minus because it is flowing from negative to positive. So minus 240 plus this one 13I1, and then plus 24, this one 24I1 minus I2, and then lastly we have this one here 30. So plus 30 I1, but I3 is flowing to the other direction, so minus I3, and this will equal to 0. And first let's move that 240 to the right hand side, so I'll have 13 1, and let's distribute this. So plus 24I1 minus 24I2, and then plus 30I1 minus 30, and that will equal to 240. Okay, let's group all together. So this has V1 I1 in it, and all the others are not. So 13 plus 24, what is it? 37. Oh, the number is not good. Yeah, 37. 37 plus 30. 37 plus 30 will be, what is it? 67. 67 I1. Yeah, I don't think I made mistakes here. 37 plus 30, yeah, okay. Minus 24 I2 minus 30 I3, and that will equal to 240. Okay, that is for the loop 1. So now let's do at loop number 2. Okay, the sum of the voltage will equal to 0, and because our focus is at loop 2, so here we have 24 here, 24 of I2, but I1 is flowing to the opposite direction, so minus I1, and then plus 10I2, and then this one plus 20, what is it, 20 I2 minus I3, okay, I3, and all of this will equal to 0. Okay, let's distribute this. So 24 I2 minus 24 I1 plus 10 I2 plus 20 I2 minus 20 I3, and that will equal to 0. And let's group all of them together. So we will have all that have I2 here, highlighted. So I'll have 30 here, 30 plus this one, which is 54, right? 54. So I will have minus 24 I1 plus 54 I2 minus 20 I3. yeah, minus 20i3, that will equal to 0. And then we still need to do one more loop. So one more loop at loop 3. Again, we use KVL. It is sigma v is equal to 0. And for this one, we will have from this one 30 i3 minus i1, and then plus 20 i3 minus i2, and then plus 50 i3, and that will all equal to 0. And so we'll have 30 i3 minus 30 i1 plus 20 i3 minus 20 i2 plus 50 i3, and all of this will equal to 0. And let's highlight all the i3. So you have 30 plus 20 plus 50. So all of them will get us to, what is it? 30 plus 20 is 50, 50 plus 50 is 100. Okay, 100 i3. And then for i2, it's minus 20 i2. And then this one will be minus 30 i1. And that will equal to 0. And so from here we have three equations with three variables. So this is equation number 1, this is equation number 2, and this is equation number. Okay, now let's just select that equation. This is equation number 1. This is equation 2, and and this is equation number 3. Okay, let's copy that and make a new slide. Okay, now I have three equations with three variables. Okay, and yeah. Okay, our task is to finish all of this. Okay, now what can we do from here? I think, yeah, Wolfram Alpha may be good for solving this. Let's see. Let's see it. Wolfram Alpha. Okay. Okay. Let's see. Solve. Okay, I name I1 as X and I2 as Y and I3 as Z. So solve. X plus A minus 24Y minus 30Z is equal to 204. Comma 20x plus 5y 20 z, that will go to 0, and more equation, minus 30 x minus 20 y, and plus 100 z, that will equal 0. Okay, we got this x, y, and z. So I1 is 6, y is 18 over 5, and I3 is 63 over 25. So let's copy paste that. Let's copy paste that. Yeah, to our slide, so I don't go back and forth. So from here we can conclude that I1, here, I1 is 6 ampere, and I2 is 18 over 5 ampere, and I3 is 63.25. So what can we get from here? So the question is to find out I. Okay, let's copy the problem again. So the problem wants us to find I, but in our case I is equal to I1, right? Because I is here and I is the current in this loop, and that is the same value. So I will have I need to use the pen, the highlighter. So I is equal to IA, and so I should be 6 ampere. Okay, and then because the voltage will be 260 and the current will be 6 ampere, we can find the resistance simply using Ohm's law. So the voltage divided by the current. The voltage will be 240, and then the current will be 6 ampere, and so that makes the resistance is 40 ohm. So the resistance is 40 ohm. So we get the current I is 6 ampere and the resistance is 40 ohm. And I think that's all the problems from chapter 2. Hopefully I did not make any mistakes, but maybe I did in some problems. So let me know in the comments. And see you. Bye bye.